This video covers the basics of designing matrix plots. Now, what are matrix plots? A matrix plot is a collection of plots or pictures organized in a grid, and it's a great way of showing a series of related information. And especially basic scientists love this format. However, making a good matrix plot is not easy. There are extra challenges to clear vision and clear understanding. Let's go back to the first principles I've talked about in previous videos. Graphing data should be an iterative experimental process designed around answering the 3 questions on the slide. And most importantly, when you're thinking about a matrix, don't use it to combine many graphs without a clear relationship, because the matrix plot will be less than its components. A matrix plot is very busy, so it's even more important that you highlight the data using the steps I've described previously. For instance, you would want to make sure that there's not too much repeating elements that are obvious from other parts of the matrix. You'd try to use the same scale across each of the panels. You'd try to avoid a grid because it makes the slide or the graph even busier, and you have to pay extra attention to your data and scale line rectangle. Making the data stand out in the midst of all the clutter is even more important than with a single graph. You have to make every pixel count. You have to make sure that you use visual prominent graphical elements to show the data, avoid data series overlap, and with a matrix graph, it cannot really be reduced, so you should design it for the size at which it will be printed. Clear understanding involves telling a story. With matrix plots, you have to organize the data around that story. That means your graph reads from left to right and from top to bottom, and the panels should be organized in that way. It's like a simple graph, but it's just more work to get it right. Finally, your text labels and your figure caption become even more important because it has to describe all the elements of the matrix. Let's have a look at a worked example. This is a very nice matrix plot I downloaded from recent issues of ARD. It looks crisp and clear, and the data is well presented. The layout on the page is not optimal, and there's some elements of this graph that can still be improved. Let's zoom in on panel A. As you can see, there are 2 data series, one indicated by black dots and one by white dots. The axis lines and tick marks and the axis labels are very thick, and the y-axis label is vertical. The panel also contains a legend. The first step is making the axis lines, the tick marks, and the axis labels thinner. The second step is taking the y-axis label and putting it horizontally on top of the graph, in this case left aligned to the y-axis. And the third step is removing the legend. Now I'm subtracting some data ink by taking away half of the error bar and removing the little t on top and bottom of the error bars. Now I'm emphasizing the data by making the lines thicker and replacing the dashed line, which is usually not a good idea in line graphs, into a continuous line with a grayscale. I can use the format of this panel and save it as a template in most graph programs, and then I can use that template to redesign the other graphs. The next step is putting the small graphs, each of the separate panels, into the matrix structure, which in this case is 2 panels across and 3 down. There's several other things that I've done in this graph, which are not immediately obvious if you don't read the article. Scaling is very important in matrix graph, and in this case it is not possible to create single scales, so each panel has a different scale. However, I've looked at the article and I've made the scales of the left set of panels to be the same percentage of the maximum score, which is 30 for the top panel, 90 for the middle panel, and 60 for the lower panel. In each case, this is about 25% of the maximum score. And then for the right set of panels, which describe the change in score, that change is the same proportion of the scale of the left panel. So in the top panels, the change range is plus or minus 1 versus an absolute score in the left panel of 30. In the second set of panels, the change is plus or minus 3 and the maximum is 90. And in the third, it's plus or minus 2 and the maximum is 60. In this way, I create a regular rhythm of scales, which makes the matrix more consistent. There's some final tweaking to be done. When you make your first matrix, usually the axes are not aligned, so you have to make sure to do that before your figure is done. Also, there's a little detail that I want to point out to you. There is an axis offset, and in the original graph, the offset is both on the y-axis and on the x-axis. The reason to offset the axis is if you have observations that otherwise would fall on the axis line. In this case, if we didn't have an offset, the data points would fall on the y-axis line. There's another additional tweak. You can see that the gray series also has a little horizontal nudge so that it's not right on top of the black series. However, we do not need an x-axis offset because there's no danger of missing points. So I've pulled the y-axis down so that the 0 is now horizontal with the y-axis. The final two tweaks are that I've reintroduced the legend now in the bottom right panel, and I've changed the labels of the graph. As you can see, the top two panels read CT erosion score, and then the right-hand panel reads change in score without repeating CT erosion, and the label is only on top so that it's not repeated across the matrix. The x-axis labels are only placed at the bottom of the slide. Just to see what it would look like, I pasted the redesigned matrix graph into the original ARD publication, and as you can see, I can make the graph smaller so that it now fits on one column, but it's still more clear than the original version. So these are the basics for improving your matrix graph design.